Hi, and welcome to Digital Tech Lunch at FINN. We are blessed by the response of this event. So thank you for showing your interest and what's happening at FINN, but also for joining us today. Today's theme is all about micro frontends at FINN. How we move the company from having frontend built as a large monolith into frontend composed by small micro frontend services. Richard Walker and Trygve will take you through this journey. After the presentation, there will be time for Slido, so please share your comments, questions, or thoughts at #TechLunch. I will guide you through this during the presentation too. Now, give it up for Trygve and Richard.
Hello everyone. It's a little bit weird not seeing people in front of you. We normally do presentation in front of an audience, but I guess we're not doing this during this time. So I'm gonna do a small introduction, and to do so, I just need to first share my screen here. I hope we get that up.
Cool. Trygve and I work on the front-end platform team at FINN, and so all the stuff we're going to be showing today is stuff that we work on during our regular days at the company. Cool.
Yeah. And one of the things which is important to know when we talk about this is basically how FINN has evolved over the years. So FINN has evolved from being kind of course, back in the days, a very small team, but FINN has grown over the years. And in the beginning, everything was just like in one code base. It's kind of the typical monolith application. And in a monolith application, you kind of just like have everything in the one application. You have your front-end code in there, you have your business logic, you have everything from just like messaging and stuff, and you connect to one database where everything are located and stored in. And this is how FINN kind of were over the years. But the reality as the organization grows, it's difficult to work in such an environment. When FINN just like starting to reach around 100 developers, you get a lot of people checking in and out the same code, and you're kind of touching each other's code, and it becomes difficult. So FINN did over the years start applying a microservice architecture. And the first thing you normally do then is start splitting out things which are in the business layer. And kind of the backend code. So you start to rip out certain small things. You take out maybe authentication. You take out things that maybe has to do with processing imaging. You take out search. And these ones have APIs that the others rely on. And one of the things that rely on this is very typical the front end. Over the time, you also still are connecting to the same database. This shape you see here is very typical when you start moving from a monolith to kind of a microservice architecture. And you get this kind of diamond shape. The thing is, like, you still do have some issues here. In the terms of scaling, you're still very relying on everything talking with the same database. And the next logical step, and this did also happen in FINN, is that you're starting to move data into different databases and more or less kind of replicate a little bit the data you have. Still, there is one place here in this triangle or pyramid shape where is still one single point of failure, and that is the front end. You still haven't managed to make everything microservices. And this is basically where we want to head. We want to head in a direction where you have full stack services that owns everything from the front end down to the database. And this is where Finn are starting more or less to become these days. At Finn, we have what we call very autonomous teams. Autonomy is very important at Finn. And in Finn, it means that each team, they should have a full set of developers that can do everything in the stack. They should be able to handle whatever needs to be stored in a database. They should be able to do all their business logic on their own, and they should also be able to do all the front end that needs to be done for their area that they own. And at Finn, an autonomous team is normally, for instance, search, or it can be travel. That's kind of bound to different areas at Finn. But in such an architecture, especially in the front end, there are certain challenges. One of the challenges in the front end is how do you compose things together? If you look at a lot of front end architecture and frameworks today, they're very, very built towards being single page applications, or that you build everything in one application that is maybe doing rendering on the server, but also do dehydration on the client side. So how can we deal with these things? What we want to do when we have autonomous teams is to be able to split our pages into different parts. So different teams can own different parts of a site, and then we stitch it together into full pages. Another thing which is kind of challenging, which is a little bit different if you look at microservices in the backend, is that in the front end, everything on the site is kind of tied together. Even if Finn is split into different small sections or pieces, and different sections is owned by different teams, Finn should still feel and look as one site. It should still feel like there is no difference in the technology or how it's built on the service side as the user moves through Finn. So one of the things we have to deal with is how do we solve this when we start breaking up the front end into smaller parts. Another issue is also how do we deal with performance in such an environment. If you have two teams that is maybe building parts of the site of Finn, they might both be using React, but when the user might be moving from the part of Finn that one team is developing to another part of Finn, they might end up with having to load React, for instance, twice, because the two different teams has been developing on different minor versions or patch versions of React. So how do we deal with these things that we can minimize the amount of assets that is loaded at the end user? And our approach to this has to be apply some patterns, which now is known as micro frontends. Some of you have probably heard about micro frontends, and it is more or less kind of a concept. It's not just one technology. And we started doing this kind of 4 years ago. Then we started splitting up Finn. And these are the parts we're going to talk about now. I'm just going to change my my presentation there because I have two presentations. And the first part I'm going to start talking about is how do we do composition at Finn. And I want to bring us back to this one. And we should all remember that we all have different teams which is developing different parts at Finn. So if you go at the front page of Finn, if you go at FINN.no and you see the front page, that page is owned and developed by one team. They have ownership of that one. If you then do a search and you end up at the search result page and where you can continue to search, you're actually at another team at FINN. Search is owned by a different team. And these are two different applications. The front end and the search are two different applications. Also, if you go to travel, that's a third team owning, and it's a third application at FINN. So at FINN, we are splitting applications by differences in the URLs. So that is one way we are splitting the applications. Before we go further, we also have to think a little bit about what is a component. In FINN, when we look at a page, in this context of stitching things together, we are looking at maybe a little bit bigger areas in what we define of a component here. So for instance, a header and a footer, that is a component at FINN in this context. And when you see the header, that is on the front page, but also at the search page and also at our travel pages, that is the same component which is included in the different teams' applications. And these are components that is actually running and is being included in these different teams' applications. When we talk about components, we're not talking about the small bits and pieces like input forms or like input fields and buttons and the part that does image and stuff. That is not part of what we call a component in this context. These are kind of styling and UI parts or UI components that is on top of the presentation layer in each application. So what we do at FINN is that we want to do cross-frame composition because at FINN it's also very important in these autonomous teams that we give developers a freedom to choose the technology they would like to work with or the technology that solves their issues the best. And at FINN, we do, for instance, advise people to use React. We haven't forced teams to use React, but teams are also able to choose different time framers like Vue. So at FINN, we have kind of a set of React. We have some teams using that. We have a good amount of applications, which is just like plain JavaScript and also just plain HTML. We have pages that doesn't do much decoration in the browser. They are just plain HTML and some styling. And we have a fair amount of Vue code that is using Vue for the application. So what we do at FINN is what we call runtime composition. And by composition, we're talking about how do we take different pieces and tie them together into full pages. So what we talked about is that we have header and footer. They are parts that each team is using. But they might have different frameworks. It might be that they also don't have anything that needs to be included from other parts. One of the challenges is that, one of the challenges that we need to do is to bind these things together. And I lost myself a little bit here. So what we do at FINN is that we do what we call runtime composition. And that means that we are actually composing pages on the fly as they're loaded by the end user. And another way of doing it is that we could actually do build time composition. That means that when a team has their application, maybe a React application, they could take the header and include that as a component in their build step. The problem with that is that we might also have a React team that also using the header. So that means that we would have to have the header in two different ways to be included in the different frameworks. We would have to make the header as a React component and as a Vue component. And then you have the pages, which doesn't use the framework at all. It's like plain HTML pages. How do we include that in a plain HTML page? We would have to deal with 3 different types of having headers. Another issue with doing build time composition is that if we put a change in the header, if we publish that, there are many teams at Finn and they have different deploy cycluses. So we wouldn't get the header out before everyone has actually made a build and deployed their application to production. But when we're doing runtime composition, we can just deploy the header, and then all our applications that is using the header, they would get that header instantly. The other thing at Finn is that we are doing quite a lot of deployments. It's very, very easy at Finn to deploy new versions of applications. But more important, it's also very easy to pull those versions back again. If we notice an error, it takes just a matter of seconds to revert that change. So that means that when we are pushing, for instance, an update to the header into production, and every application is then suddenly updated with a new version of header, and if we get a message that, oh, this broke over in this part of Finn, we can revert the header very, very quickly. And if we're starting looking at what we actually want to do here, despite which frameworks we're using, React or plain HTML or Vue or Svelte, doesn't really matter. In the end, what is kind of put together in the browser is plain HTML. These are text strings. So the DOM is more or less text strings. So if you start breaking down the HTML page, we will easily see that we can split things into components. So the header is a component, footer can be a component, navigation can be a component, and then you have the thing that encapsulates a page, a structure. That's where we kind of put components into. That is the basic concept we would like to achieve here. One way you can do this, and this is actually a technology that's been around for quite a lot of years. Some of you may be using Varnish, or you might be using Fastly or other CDNs. They have this technology built in. What you can do is that you can insert in your HTML structure some small tags, and then when you load that, the Varnish, the HTTP cache or your CDN, will take the components and compose a page together. The problem is that at Finn, this doesn't really work well. This is an approach which has been adopted by other sites, both in Norway and around the world. VG used to be like this. They're still doing it to a certain extent. I've been working on this at NRK and also at our media. I know that Amazon is doing this, but at Finn, we found this approach by using a HTTP cache to stitch our pages together, not really a good fit. There are other things we need to solve. One of the issues we found at Finn is that we have a lot of content which is actually behind login. We have a lot of content that we can't cache. So having the benefit of a HTTP cache in front of Finn wouldn't really benefit us. It would make things more complex for us. So we went down the road to actually make our own framework, which we call Podium. And Podium is a framework for composing different UI components or UI applications together. We have open sourced Podium, so if you want to look at it and see the documentation, it is available on podiumlib.io. And the whole concept is not much different than what you've seen in this ESI example. We are still looking at our HTML, where we have snippets of codes, and we have what we call a layout that is fetching the different components. So at Finn, the header is actually running as a small HTTP server that serves a chunk of HTML, the header. It can take input parameters, so you can alter the input of the header depending on if you're logged in or not. And then we have another server, which we call a layout server, that is fetching these components over HTTP and stitching them together into a full page. The whole thing with Podium, and that we're saying that this is part of composing things together, and this is the stuff that maybe makes it a little bit different from using the ESI approach as we used before, is that we also have some concepts about pulling in assets. So each part that is a component, like the header, has a configuration file. It is versioned. There is a reference to where is the main content of this component. And we're also referring to where are these components assets. And you can also define proxy fields. So you can say that this component, I need to get data back. It might be an you want to post data back from a form. Then when this layout is kind of mounting this component into a full page, it also mounts a proxy path for us. So it can do AJAX requests and post forms back through a layout and into the component. So in Podium, I am talking about what we call a component and a layout. And in Podium, we call a podlet for a pod. We call a component a podlet. That is just the name we've chosen. We could have called it a component. A little bit historical reasons why we call it a podlet, but that's how it is. And if you're using Podium, you basically make a podlet like this. And the most basic component you can make is having this configuration file, which is stored as a small JSON file. You can call it whatever you want. And then you can also have your small HTML snippet, and you can put that on a static HTTP server, and you have a podlet. But if you're using Node.js, you can use the framework, and it will give you a couple of small things for free. So what you're doing here is that we're using Express. Podium do support other HTTP frameworks. So you can use Podium in Fastify, or you can use it in Cloud Functions, or you can use it in Happy if you like. This example, we're using Express. And you define a podlet, you give it a version, You give it a name. Then you have to attach some middleware. The middleware will do some parsing of the request that comes in and pick out some values for you. Not going into depth in that, but there are some communication between the layout and podlets here. And then we have a route, which is basically serving the manifest file. So the route which is have apt get podlet manifest, it will serve a small JSON file. And then we serve our content, which is basically a small HTML snippet in this case. And then we have the layout. The layout server is then a server that fetches different components over HTTP and ties them together. And in this context, it's also the same thing. You pull in a layout module, you create a layout object, then you are registering where is my podlet, you're pointing to the manifest file, you attach a middleware that will do some processing on the incoming request, and then inside where we want to serve our HTML page, we do a fetch to the podlet. And then I get a content back. This content object do actually contain a little bit more information. It will give you the assets and also the proxy endpoints and stuff for the podlet. So you can do things on that in your layout. And this composes a page for you. You are free to use the templating language you want. You can do plain string concatenation, or you can stuff this into React app if you feel like. I have a very small presentation, a small live demo for you. How a typical setup of this would work. I hope every one of you is seeing my screen now. In this repo, I have 5 different podlets. They are small, the small applications I talked about. So if we look at the header, it's a fairly known structure. We have the server. This one is actually using Fastify. So this podlet, when I start this one, will serve a small component at port 7100. So we're now gonna start this one. Let's see. Now this one is running on port, and if I go to my browser, that was probably not the best one to start. We can start another component which is available on port 4000. Okay, this is the small let's see. Yeah, let's see. Application. This is the demo effect, I guess. Yeah, here's the component I was looking for. So this is a typical small, what we call a podlet at Finn. You're able to write your small parts. You can work on them in isolation. You can now sit here and do the styling, and you can do the functionality for this part, and it lives on our server. And if I now add this is basically the configuration file that is needed to tie things together. And if I now start all my podlets, it doesn't matter if I start layout or start the podlets in different order. They are all made to, it's all made so you can, one of them can fall out and all these kind of things. And if we look now at the layout, let's see, it looks like this. So plain Express server, and we have the different podlets which is registered, and we are here fetching them, and then we're making this into a structure, and we're sending this to the browser. So if you now load this, we will get a full page. So this is now a page which is composed of the different small parts. One of the advantages here is that it might be that a part of Finn can start having issues. So for instance, if authentication is starting to have issues, it's made so that if that one is failing, we are still able to show virtual parts of Finn. So if I stop our authentication box now, and we reload the page, we will serve a fallback that is saying that, hey, we are having issues with authentication now. You can't log in or use the parts of Finn that requires authentication. But there are parts of Finn that is still working, which doesn't require authentication. So go on and use that. And then when the authentication is back up running again, it will automatically be there. And that was more or less what I had on my presentation part. So I'm gonna stop sharing. Over to Richard.
Hi guys, we just heard Trygve talk about some of the challenges around using micro frontends in your organization, and he talked about solving the problem of composition. But I'm going to talk about a couple of other areas, starting with consistency. So if I could have the slides up large. Can I get the slides up large? Yeah, cool. All right, so consistency, when I'm talking about consistency, I'm talking about the user interface and the consistent look and feel of all of your properties, your applications, your web, and so on, when you're dealing with isolated teams. So you have this challenge. This challenge of one organization, everyone's working in isolation. They're potentially focusing on very specific areas, and those areas that they're locking in on are probably business logic things and that particular piece. And they don't really want to have to be thinking about what another team is doing with their look and feel. They just want things to be consistent and not have to focus on those things. And it can be quite a challenge. So this can be difficult when we're split up across different pages on the site. It can be difficult because there's different developers working on your mobile apps and so on. But this gets even harder when you're talking about composition, like what Trygve has been talking about with breaking even a single page into a number of pieces. In this slide, I've highlighted different parts of the Finn front page that are different pieces. I think the front page is one of the extreme examples where there's something like 11 different separate pieces loaded into a single page, owned by probably about 5 different teams. And so we need that to look visually consistent. One solution, and the solution we try to use at Finn, is to use a design system. So Wikipedia says, the design system is a set of interconnected patterns and shared practices coherently organized to aid in digital product design and development of products such as apps or websites. It may contain, but is not limited to, pattern libraries and design language, style guides, coded components, brand language, and documentation for use of all of these. Wikipedia also says, this article may be too technical for most readers to understand. So I'm going to dive a little bit into what we mean when we're talking about a design system. So thinking about a design system, generally speaking, we're talking about building blocks for assembling a UI. We're talking about the documentation part of this. We're talking about a collection of reusable components. These might be React components or web components and so on. And it needs to support multiple applications, devices, screen sizes, medians. It needs to work across the web and apps and so on. Specifically, this is pulling in your UX and design, your style guides, your design assets like iconography and so on, typography. It's pulling in everything you need to put together a web UI. It's everything you need to put together a native UI all in one place. So how does this help? Well, firstly, it provides a single place for everyone to collaborate on. You can have, like we do, you can have people from UX and design, you can have people from the front-end teams, JavaScript developers, CSS developers, all contributing to the same thing. So it's a shared location to work on the same thing. And then secondly, you can encapsulate the design into reusable pieces. React developers, front-end developers in the current age are very used to encapsulating design into reusable pieces. And this is really about doing that and standardizing on those pieces based off the design, and then providing that to the rest of the people, developers, teams in the organization to consume, to use, to implement the UIs that they need to implement without needing to worry too much about the implementation detail. And super important is documentation. And this is both documentation of the design itself, documenting things like typography and styles and guidelines and all that sort of thing, colors, color schemes, etc. But it's also documenting the components themselves and how you use them. So it's important that as a developer in some team that's focused on some particular problem and needs some particular UI solution, they're able to go to this one single site, pull the piece they need, and load it into the work they're doing, and automatically get that consistent look and feel. But also, you have this other advantage, which is that because you're componentizing pieces of the UI, you can also bake in best practices. And so things like accessibility don't have to be, or don't become an afterthought. That's something that's sort of first class. So here's just a little example of from Finn documentation for a tab component. So this particular component, a developer can come and see, okay, this is a tab component at Finn. This is what it looks like. They can change the settings right here in the documentation to see it react differently to the different settings, and then they can take the markup they need and drop it into what they're doing. And the same applies to React or Vue components or whatever as well. You need to be able to see how it will look and behave and see how you use it in one place. So Finn, up until recently, has sort of had a few of these different pieces in different places, and there's now a concerted effort to move everything into a single design system, which we're calling Fabric. And so that's our design and graphical assets, style guides, CSS, web component library, React component library, Vue component library, and documentation, everything kind of rolled into one piece with everyone working together on it. So that's basically what I want to say about ensuring that you have a consistent look and feel across your microservice or micro front-end world, micro front-end organization, across your isolated teams. So now I'm going to change gears and talk a little bit about performance as a last piece of the talk. So when I'm talking about performance here, Trygve touched on this as well, I'm really talking about client-side assets and how to make them performant when you're split up into these different isolated teams with these different micro front ends. So we saw this slide a couple of times earlier. I'll use it again. You can see on the left-hand side that the page is built out of 4 different components, 4 different pieces. And we're going to stitch those pieces together into a single page. So what's so challenging about that when it comes to your client-side assets, your JavaScript and CSS that you need to be running in the browser? So maintaining isolation while staying performant is really actually quite difficult. And here's why, or here's an example of why. So each of the pieces on the right represents by color one of the pieces outlined in the page on the left, one of the components. And you can see that 3 of those pieces all depend on some particular dependency called lib. And you can see that the first 2 depend on lib version 568, but the last one depends on 571. And in a worst case scenario, what you might get is that each of these pieces is going to bundle its own client-side assets and put them into the page separately. And that means that lib is going to be included 3 times. So page bloat, not something you want. A slightly better approach, which Finn had which we used prior to now, was to use some kind of a build server, which is able to optimize so that each of the pieces submits their code to the build server, and then some kind of optimized build is produced. And that would certainly remove one of those 2 versions of 5.6.8 because it's able to just dedupe that out. But it's very difficult for a build system to know which one should I prioritize, 568 or 571. And if it picks one, what's going to happen? Perhaps some code in one of these pieces will break. So this is not a great solution either. So what we've done is we've taken a step back and we've looked at using a bunch of modern techniques and tools to try and take a fresh look at this problem and solve it in a new way. And what we've come up with is something we've open sourced called Ike, which is kind of basically a CDN with an upload client and some smart stuff built in that kind of solves our specific needs. And some of you might be familiar with Unpackage or Snowpack, and these things are similar in a way. So let's have a look at some of the things that we're kind of building on top of, or we're using the pieces that make up Ike. So one thing that's really important is ECMAScript modules, ES modules. Many of you will be familiar with this as front-end developers. Here's a quick example. In our client-side code, we would import some particular dependency into our code using syntax like this. And in the first case, we're importing from a relative URL, but in the second case, which is kind of key to what we're doing here, we're importing from an absolute URL, which is also possible. We're also leveraging HTTP2 because instead of bundling everything into a single bundle, we're now actually having to load a couple of different things at once. And HTTP2 is much more performant in that area. We're also using a new emerging standard called import maps, which I think has just been unflagged recently in Chrome. And import maps allow us to map from the name of a particular dependency to a specific path or URL. So what we call a bare import to a path or URL. So what this looks like is, here we have an import map definition. It's just a little piece of JSON. It's going to map from some dependency called foo to some particular URL. And this might well have been React to some particular URL. Then when we import foo, we can apply an import map transformation to that, and we end up with the code actually referring to the absolute URL from the import map. The final piece in all this is something called aliasing. And this is where we take a general version of a particular dependency, and using HTTP redirects, we map to redirect to a specific version of that dependency. So as an example, the top in green here is a general aliased name, v5. And that v5 is going to redirect via an HTTP 302 to version 5.7.2. So we'll see why this is important in a bit. So let's try and pull those pieces together into a quick example before we wrap up. Let's say we're looking at the header component. So what we're going to do is we're going to take the client-side assets for that header. We're going to apply any transforms we might use, which might be maybe we're using TypeScript or Babel, what have you. We use something like rollup, and we apply import mapping to that code. So our code might have statements like we saw earlier with import lib, and we're going to map that to a specific URL during the build process. And And then we're going to minify the code and upload it to the CDN. And then, so now revisiting our problematic composition from earlier, you'll notice the main difference in this slide is that everything is using ESM now. It's using import statements instead of require statements. But you can still see that 3 of the pieces are still depending on lib, and 2 of the pieces are depending on the same version, and 1 is depending on a different version. But once each of these pieces is run through their build process prior to publish, those import lib calls are going to be replaced with specific absolute URLs to version 5, the aliased version of that dependency on the server. So suddenly they're all lined up. They're all pointing to v5. They're not pointed to different versions. So that's part of the problem solved. Now, when the browser actually makes a request to the page, it's actually going to get redirected to the specific versions, 5.7.2, in all cases. And now we're basically leaning on the browser to let it do the work for us, because we're saying, okay, well, you handle it, browser. And the browser goes, cool, I see that you've got 5.7.2 included 3 times. I only need to fetch that 1 time, and I only need to parse it 1 time. And then I can just use the same code in all the other cases. So you've got basically free deduping right out of the box for doing that. And then one nice thing with the aliasing also is that we're then able to transition pages from one version to the next via the alias. So we can update the alias on the fly without having to redeploy the apps. We just say, hey, v5 now points to version 5.7.3. And so when the app refreshes the next time, when you refresh the page or a new visitor comes, they'll just get 5.7.3, and everything will be aligned on that version in one go. So that's great. And then we get one other nice advantage for doing this, which is code splitting across the entire site, which is to say, if we were to visit the front page of the site, in this example, inc.com, we're going to import header, side, main, and footer. And that's fine. The browser's going to load all of those 4 individual pieces. But then we're going to move to /foo as a route. And the header, the side, and the footer have already been included. So it doesn't need to, they're cached now in the browser. It doesn't need to fetch them again. It just fetches the pieces it needs, and so on as you traverse the website. So that's all I had to say about performance. I see we're actually running pretty tight on time here, I think. I'm going to bring in Trygve now. He was going to say a little something before we take any questions we have time for. So that's it from me for now.
Yes, hello. Want to say a small thing. The thing is, like, we are actually we are hiring. So my team that me and Richard is working on, we call an infrastructure team at FINN. Our main goal is to help the other teams to make the stuff they need to make. So all the things that we've been talking about here, the style guide, Podium, React components as we have, also the AIC, the CDN that we have, that is all built and maintained by my team. So despite that we have autonomous teams, as you've seen, there are things like the style guide, because FINN needs to look similar everywhere. There are things that needs to be worked on across all teams. And that is my team's responsibility. And we are currently looking for developers. My team, we do a lot of these things open source. We're trying to move more and more open source. Podium, AIC, all our React components, our style guide. We have web components, view components. They are now all moved open source. So if you want to poke around in the code, if you want to work on open source with us, if you like working and looking at new technology, we're able to play with a lot of new stuff and ideas, which is super fun. We are, of course, looking for people. We are also looking for other people, backend developers and frontend developers for other teams. So check out what we can offer. I think there's time for a Q&A, isn't it?
All right. So I guess we start by just taking the ones at the top. I can read them out maybe. Oh,
Yeah,
jump around a bit
let's
though.
see.
With many autonomous teams around, who owns global components like header, footer, navigation, or main component? It's kind of
Shall I
us.
answer? Well, so global components is kind of owned by our team. It's like we are an infrastructure team. And the process is that we try to make things that is kind of needed out there. But at the point you get to, that's like, okay, we own this set of components. So for instance, my team do actually own the header, and we also own the footer, as an example. We also own style guide. But there might be needs, for instance, in the style guide. It might be that a team has developed some parts that's like, hey, this is a nice feature. We want to reuse that, and then that code can be moved from that team and into a shared library or a shared component. So the level of moving things in and also other team members to collaborate on things is very low at Finn. We're trying to have it as open as possible, but it is my team who own a lot of these shared components, even if there is developers in other teams working on them.
Yeah, absolutely. So how do you deal with versioning of libraries that needs to be declared globally? Previous versions of React required a single global instance.
Yeah, this is where the aliasing in Ake comes into play. So our approach to this is that we are basically mapping out the different versions. And by doing so, we have removed quite a lot of duplicates, and you will end up with just one React on the same page. The thing here is that we're using somewhere for versioning. So if you look at the URLs in Ake, it's very deliberate that we're using somewhere, because that makes us to use the logic in somewhere. So because there is a danger of breaking changes here. So what we're saying is that patch versions and minor versions, we're fine updating those in production, and it change on the fly in each application when you do such an update. The win is that we're solving the problem that's pointed out here. And then if there's a major version, that is actually kind of a new alias. And that is something that we put into production. And then we're going to saying to each other team that within this point in time, we would like you to switch to version, a newer version, which is major. And the reason for that is that major versions normally have breaking changes in them. So it's a way of handling that. And by doing it so, we also give each team time to actually test out newer versions. So Ake solves a lot of these issues for us.
Yeah, absolutely. Wouldn't multiple frameworks create a maintenance challenge in the long run?
Yes and no. So currently we're doing a small transition. Each team are free to choose the framework they want to. And that means that each team can move as fast as they want. It might be that the skill set of the developers you're hiring are much better in one type of framework than another type of framework. And currently we are maintaining components for different frameworks, and that is a little bit overhead. What we're starting to look at is using web components for making reusable components that can be plugged into different frameworks. So in the future, we would like to replace maybe all React components and Vue components with web components, actually. And then each team use React or Vue or whatever they want for the other type of logics like state management and all these kind of things. So at the moment, yes, a little bit overhead of maintaining different frameworks, but future there might be not so much overhead. And this is also one of the reasons we have been waiting a little bit to start looking at web components until 1st of January this year, because 1st of January we did kill off IE 11. By doing so...
What Trygve was saying was that in the start of the year, we basically killed off Internet Explorer 11, which sort of opens up a number of possibilities for us generally. So yeah. Oh, and you're back.
Yeah. How?
All right.
I think I lost.
So I did my best to just finish off there. The next question is how does the different components talk to each other? Do they use?
Yeah, there are two parts of here. It's like backend wise, Finn has a very event-based architecture. So each backend microservice or whatever, and to exchange data, we send events, a lot of events. We are a heavy user of Kafka, but also in the browser. I guess this question is more tailored for that. You need to send events between each component in the page, and Podium actually comes with a small module for that. That kind of makes a small global Podium event bus, and each component or part that you put into a page can subscribe to events and emit events. So yes, we do event sourcing. Yeah. It's kind of like a PubSub thing in the browser.
Yeah. You mentioned that teams can use whatever library or framework they want. Do you, or how do you prevent React, for example, from loading in multiple times on the same page? If you think about what I talked about with in my examples, I was using lib. If you just replace that with React, that's essentially how we're dealing with this problem. We're mapping all versions of React to a specific global version via the aliasing mechanism, and which we can also transition over time. So we should both see that within a single page, no shared components will use the same. React will only be loaded one time within the same page, even if it's included in 3 different components. But also because that version will be cached in the browser as they move across the site, they should also end up just getting that deduping for free when they try and load the exact same version of React. I don't know if I did a very good job there. If you want to add anything further.
Yeah. Next question goes into the same category, actually. So the thing is, one of the things that we're doing is that we're trying to not make components. It's like if you a page contain components from one team. It's like one application. It's like search is an application, but we also have components that comes from other teams. It's like include, which is shared among different teams and applications. We try to write those parts that is shared between different applications in a way that they actually are not dependent on a framework. And these are the components that we are first moving into being web components. So for instance, the header as it is today is plain text HTML rendered server-side and decorated with plain JavaScript. So this one is actually not written as a React app. But we would like to move it to a web component so we have more isolation and gives us a lot of the niceness with which web components do. So we're trying to not mix these things. Components that is shared between different teams, try to not use a framework, and then each team can use the frameworks they need for the parts which is just them and composing the whole page.
Right. I see that we're after 12 now. We're over the hour. Should we take one more question just to finish off and try to keep it short? How to deal with bundle size? What's the benefit of having different frameworks? Do you really solve any big problem with micro frontends?
Yeah. So there's a lot of people with opinions when it comes to micro frontends, and the thing with micro frontends is that we are solving a lot of things, actually. The thing with bundle size is dealt with Ake for our part. We're going to do Ake is fairly new for us, and we're starting to fine-tune and really working on optimizing and squeezing down what is loaded in the browser. That is going to be our main focus the next coming months, probably. But what micro frontend really solves for us is to be able to push things to production quickly. When you do a change in a component that is shared across different applications, we get that out really fast. It's a deployment and it's updated everywhere in a couple of minutes, and we can roll back the other way. If everything were just components that each application had to include and do a build time, it would take maybe days and weeks before we actually got those changes out everywhere. And if there's an error, we would have to also spend days and weeks actually rolling these things back. And that is a huge positive for FINN. It is also a very big positive that we are able to let different teams use different technology stacks. We know that front-end libraries come and go. We have started to see a small change at FINN in fair amount of React application, kind of now moving a little bit to Vue. People are curious on Vue and are starting to feel some React pain. So it gives us the possibility also to move parts of FINN gradually.
Yeah, and just keeping in mind that, and really doubling down on the fact that technology does change over time, and embracing that and saying we understand that and we can roll with it is kind of a big win for a large organization like FINN. We can't afford to greenfield rewrite to everything from scratch every few years when people decide that the next framework needs to be used. So cool. All right. Well, then there we go. We've hit 12.
I'm gonna maybe reply to the next one. Like, okay. I think we have time for that.
All right.
Yes, we have looked at other frameworks. It's like we have looked at Mosaic and we have looked at Single Spa. When we started with Podium, Mosaic from Zalando was very, very tied to Zalando. And there's a lot of infrastructural parts in Mosaic, which ties it to a certain points of infrastructure. We wanted something which was kind of more flexible. We wanted it to be possible to just have a plain HTTP server with a JSON file, the Podium config file for a podlet, and a plain HTML. It should be possible to write the podlet in Java, in Ruby, in Go, in Node if you want to. Single SPA wasn't around when we started looking at this. It came later, but single SPA is very, very single page application focused. At Finn, we still want to do quite a lot of server-side rendering of markup. So
yeah, Podium's not a new thing. We've been working on this for a number of years at this point. So, yeah. All right, let's wrap up there. I don't know, Frida, did you want to say anything, or how does this work?
No, I'm fine. I'm good.
All right. Okay. Then I guess we say goodbye from us.
Yeah. Goodbye.
Okay, she says wrap up. Okay, cool. All right. Thanks, guys. See ya.
Bye-bye.
Ja, da var det Hustad. Oi.
Ja, promp er jo helt naturlig. Og noen er det jo litt lukt på, som jeg kanskje kjenner litt nødt nå. Ja.
FINN.no